So we're doing 1-1, day 1, polynomial long division, because this is unit 1, lesson 1, and then it's day 1. Tomorrow is unit 1, day 1, lesson 2, and then we will continue on. This, I think, is probably one of the more difficult IM3 concepts we do in the entire year, so we're starting with the most difficult one. But I did go a little bit more slowly today than I have in the past, and I think it makes a little bit more sense this way. So I recommend that you get out some colors. You're probably going to want to use colors in your notes. You'll probably be okay with 3 pens and a highlighter or so. Okay, if you don't have any, ask your neighbors, but I do recommend it. I think it'll help you. We're going to start with arithmetic long division. This is a recall back from elementary school, because today we're doing polynomial long division. So I need to make sure you know how to do arithmetic long division first. So I have 673 divided by 7. How am I going to divide this or do it on my paper? What do I have to do? Do we remember? Do you know how to set this up? Yeah, I got to put the little thingy. Yeah, like this, right? Okay, what else do I do? What goes where? Okay, 7 goes outside. Why? Not because it's smaller, it's because I'm dividing by 7. Because if I had 7 divided by 673, does 7 still go on the outside there? No, and yes, I can do that. It'll just be a fraction. It'll be a very small number. Okay. So in this case, it's the number that I'm dividing by goes outside. So where does the 673 go? It goes inside like this, right? Do you remember this from many years ago? Okay, what's my next step? How do I divide though? Okay, 7 goes into 6. Does 7 go into 6? No. Does 7 go into 67? Yes. How many times? 9 times. Okay, good. So what is 7 times 9? So what do I do with the 63? I'm going to subtract it. Okay, good. What is 67 minus 63? 4. Good. What do I do next? Okay, so does 7 go into 43? Yes. How many times? 6 times. What is 6 times 7? 42. And what is 43 minus 42? 1. Okay, so now there's 2 ways we can finish this problem, right? I could put a decimal and then find everything else after it. Do you remember doing that when you were younger? I can also write remainder 1, can't I? Isn't that what you've originally learned how to do? The way I want to write my answer is 96 and 1/7. Why did I write 96 and 1/7? Yeah, because the remainder is 1 and 7's my denominator. Because if I wrote this as a fraction, it's 673 divided by 7. 7 is the number that I'm dividing by, okay? So when I have a remainder, I'm going to write the remainder over whatever I divided by. Does that make sense? Is that okay? Because we're going to use that right now. So our first example is a polynomial long division, okay? Here's our first example. Wow. I know you're sighing now. Just copy it down. It's going to be just like what we just did. I'm going to show you. That's the reason I wanted you to use colors. It'll make it a little bit easier, okay? Just write this down. Just write it down first. Okay, just write it down. And then what do we do every time we have long division?
Run away.
Not run away. What else do we do when we have long division? What do we have to do on the first one? What do we write? Our little symbol, right? So it's the same idea. I'm doing a polynomial long division problem, and I'm still going to write it the same way. Now, what goes inside? 3x squared plus 17x plus 10, because that's the thing in the numerator if I were to write this as a fraction. And what goes outside?
3x plus 2.
3x plus 2, because that's the thing that I'm dividing by, okay? You follow me so far?
Yes.
Do you know how to fill this out? Just up to here. Do you understand where to put each of the terms? Okay, because that's important, because I see sometimes we flip them and then do this weird, I don't know what kind of division it is, but you need to know the number that's going to be the denominator goes outside. Okay. So I like to circle this first term because I use it in everything for the remainder of this problem, okay? And then I'm also working with the leading term inside. So right now, I'm only looking at 3x, and I'm looking at 3x squared. You follow along so far?
Yep.
Okay, on the last problem, I said, does 7 go into 6? No. Does 7 go into 67? And we said yes, right? We had to figure out how many times. So pretty much we did 67 divided by 7 and figured out how many whole times it went in. We're going to do the same thing. So I like to write off to the side 3x squared divided by 3x to figure out how many times does 3x go into 3x squared. It's 1. And what's my remainder? What's 3x squared divided by 3x? X. So that means when I multiply these two together, I'll get 3x squared. Do you agree with me? Okay. So this thing that I got, that x, is going to go up here. Okay. Whatever I get each time is going to go up there. Now, and I want you to watch me, because if you look down and look up, this is where you get lost easily. Now, I'm going to multiply each of these terms to that thing right there. Whatever it is. In this case, it's an x. It won't always be. But what is 3x times x? 3x squared. And where do you think that's going to go? Underneath. So I'm going to put 3x squared. What about 2 times x? What's that? 2x, and it's positive, so I'm going to write a plus 2x. And what did I do when I got to this step in arithmetic long division? I subtract, but in this case, I don't just have one term, do I? I have 2 terms, so I need to make sure I subtract them both. So what I do with the subtraction sign, remember last week, with that negative, what did we have to do? Every time we subtracted, we had to change the sign because we distributed it through. So since this is positive, I'm going to just subtract. And what about that 2x? What do I do with it? It's also going to be a subtraction because I have to change the sign. Do you understand that part so far? So pretty much I have parentheses there, and I just distributed a negative through. What is 3x squared minus 3x squared? 0. Good. And what is 17x minus 2x? 15x. Good. What do I do next? Bring down the 10, just like how I brought down the digit before. Do you follow me so far? Okay. So now I have 15x plus 10. What is my new leading term in here? 15x. That's the first term. That's my new first term. So I'm going to come over and do 15x divided by, what number do I divide by each time? 3x. Good. What is 15x divided by 3x? Where does that 5 go? Up to the top right here. We follow so far? Is that making a little bit more sense the second time around? Okay. So now I'm going to multiply to 5. So what is 3x times 5? 15x. Good. And what is 2 times 5? Positive 10. And now when I subtract them both, I change both of those signs. So it becomes a negative and a negative. So what is 15x minus 15x? And what is 10 minus 10? 0. So do I have a remainder on this problem? No, I don't have a remainder. So that means my answer then is x plus 5. Here's our second one. Now I have 5n cubed plus 13n squared minus 26n plus 8 divided by 5n minus 2. Okay, so how do I start by setting this up?
Put the thing.
Yeah, put the thing in the thing.
Yeah.
Is this what you're talking about? Okay.
What's that thing called again? The thing.
I don't know. It has a name, but I don't know the name for it.
The thing is called.
It's not a house. I'll look it up and we'll figure it out. A sideways L. I think it's just a long division symbol. I don't know if it has a name, but I can find out and let you know. Okay, we filled it out like this. Are we okay as far as that goes? Okay. Then, remember, I like to circle my first term so I remember that's the one I'm working with every time. Now, do I do this 100% of the time, every single time that I do this, all the time? I don't, because I've been doing long division since I was in the 8th grade. But you should until you get really comfortable with it, okay? Because I want you to make sure you know where these numbers are coming from. And like the part that I write when I divide on the side, I don't do that all the time. I'm doing that because I want you to see where those numbers are coming from. But if you can do it without writing the division every time on a test, I'm not going to take points off for not showing that part of your work, okay? So, what is my first term that I'm working with? 5n cubed. So I have 5n cubed divided by 5n. And this part right here, that's what I'm talking about. I don't write this every single time that I do my work. But if you need help and you need to write that as a reminder, be my guest to do whatever you need to remember the steps of this, okay? What is 5n cubed divided by 5n? 1n squared. Because 5 divided by 5, and I have 3 and 1, which becomes 2 like that, okay? So the n squared comes up top. What's my next step?
Divide it. I mean multiply.
Multiply. And I'm going to multiply 5n to n squared. What is 5n times n squared? 5n cubed. And as a reminder, it should match that thing exactly because it should be a 0 pair. And if it's not, you multiplied something wrong. Okay, what about negative 2 times n squared? Negative 2n squared. Good. What's my next step? Subtract. So what does that do to all those signs? Good. So this one's going to become negative. What about the negative 2n squared? What happens? That one becomes positive. Okay, does that make sense? Okay. What is 5n cubed minus 5n cubed? Good. And what is 13n squared plus 2n squared? Perfect. And what do I do next? Bring down the negative 26n. Okay, now what's my new first term? 15n squared. Is the color coding helping you see where everything is? I hope so later. Because then you look back at your notes when you're doing your homework and you're like, I have no idea where any of these numbers came from or what I just did. I know you. Okay, what is 15n squared divided by 5n? 3n. Perfect. So that's going to come up top, and it's positive 3n. And again, I multiply through. What is 5n times positive 3n? 15n squared. And what is negative 2 times positive 3n? Thank you. Negative 6n. I heard one of you. What do I do now? Subtract, which means I change all the signs. So 15n squared minus 15n squared is 0. And what is negative 26 plus 6n? Negative 20n. Now what do I do? Perfect. Bring down the 8. Now what's my first term? Negative 20n. Good. And I know I'm going slow, and this kind of takes a while because there's a lot of steps to it, but I would rather you take your time than rush through and miss a step, okay? What's negative 20n divided by 5n? Negative 4, right? So I'm going to put the negative 4 up top. Multiply through. Whoops. What is 5n times negative 4? Negative 20n. And what is negative 2 times negative 4? Positive 8. And when I subtract, what happens? All of my signs change. So what's negative 20n plus 20n? 0. And what is 8 minus 8? 0. So do I have a remainder? No. So what's my final answer? Good. Does that make sense so far? Can you try one on your own for me? Okay, we'll put the next one up. I think you can get all the way to the last step, and then some of you are going to be like, I don't know what's happening, but I want you to try the next one. I'll go over it with you in a minute, okay? Okay, so we have to fill this in first. So I saw pretty much every single one of your papers, and you all had this filled in correctly, yes? You did this right? Okay. So I have 2p cubed divided by 2p, which was p squared, yes?
Yeah.
Okay. So if I multiply it through, whoops, I have 2p cubed, and this is where I saw a ton of mistakes. Negative 3 times p squared is negative 3p squared. A lot of you were doing 3 times 2p and getting 6. You don't multiply these together. You multiply that together. Does that make sense? If you made that mistake, please fix it. So I'm going to subtract. 2p cubed minus 2p cubed is 0. And negative 11p squared plus 3p squared is negative 8p squared, yes? Am I right so far? Okay, then I'm going to bring down the 16p. Is that okay so far? Now, negative 8p squared divided by 2p is negative 4p, am I right? Okay, so that's going to come up because my new first term is negative 8p squared. So I'm going to multiply through. 2p times negative 4p is negative 8p squared. Negative 3 times negative 4p is what? Positive 12. Negative 3 times negative 4 is positive 12p. Now, maybe this is why you said that. In the next step, what do? I subtract, which changes all of my signs. Negative 8p squared plus 8p squared is 0. What is 16p squared? 16p minus 12p. Good. And what do I do next? Bring down the 1. Okay, so now my leading term is 4p. So I have 4p divided by 2p, which is 2. I'm going to multiply through. Are you all doing it okay so far? Okay. So 2p times 2 is 4p. Negative 3 times 2 is negative 6. And when I subtract, what is 1 plus 6? Do I have 0? Did I get a remainder this time? Yes, on the last two I didn't have a remainder, did I? And I didn't tell you what to do with remainder, did I? So I'm going to write my answer the same way. So I have p squared minus 4p plus 2. Now, what was my remainder?
7.
So it's a plus 7 divided by, what was the thing that I divided by? 2p minus 3. Just like in the beginning when I did 1 over 7. Remember, my remainder was 1 and I divided by 7. Here my remainder is 7 and I originally divided by 2p minus 3. So this thing right there, when I have a remainder, whatever that is, what I just highlighted, that will be my denominator of the remainder. Does that make sense? What'd you say? Yes, this right here is my final answer. Does that make sense how you write that? Okay, so if there's no remainder, don't write anything. What if I had a negative 7? What would I write for my remainder? Right here, would I still write plus 7? No, I would write minus 7. Now, I have one last question. I know the bell is about to ring. What would happen if I didn't have a p squared term here? How would I do my division? I need to put a placeholder there, so I would have put a plus 0 there. So if I'm missing terms, I need to put a 0 anywhere there's a missing term, okay? Okay.